So today what we are working on is looking at the sum and the product of the roots. And what you can do is if you know your roots, you can figure out what their sum is, figure out what their product is, and it actually helps you write your equation for your quadratic much easier than actually taking things and multiplying it out. So let's say we are given two roots. We're going to call them root 1 and root 2. If we want to find the sum of them, all we have to do is add root 1 plus root 2. That would give us our sum. If we want to know the product, all we would have to do is multiply root 1 times root 2. And that gives you the sum and the product of your roots. So again, that's if you know what they are. If you are given a quadratic equation, again, remembering what standard form is, ax squared plus bx plus c. If you want to know the sum of your roots, it's negative b over a. So again, b value comes from in front of the x, a is in front of your x squared term. Your product is c over a. So c is just your last number, and again, a comes from in front of your x squared term. So whether you know your two roots and you can actually add them or multiply them, or you have your equation, you can always figure out your sum and your product of your roots pretty quickly. So let's take a look at our first example. They want to know what is the sum and the product of the roots of 5x squared equals 20x minus 1. So first thing we have to do is get it into standard form. So get everything over to one side of the equal sign, have it equal to a 0 on the other side. So first thing I will do is subtract my 20x. So if I do that, right now it's equal to a negative, so I am almost there. So just add my 1 over. And then we are in standard form. So 5x squared minus 20x plus 1 equals 0. Standard form. So kind of like when we're doing our quadratic formula to sum, we want to identify what in our c term. So a is a 5, b would be negative 20, and c would be a 1. So to figure out the sum of the roots, because we have the equation, we would want to use the little formula up above, negative b over a. So our b value is a negative 20, so we're going to have negative 20 over our a, which is a 5. So what is negative 20? Yeah, turns into positive 20. So 20 divided by 5 would be 4. The sum of our roots is 4. So then the product would just be c over a. So our c value from our equation is 1. A is a 5, so our product would be 1/5. Just leave it as the fraction if it ends up being a fraction. So 2 is asking us to go about it a little bit differently. They want us to write a quadratic equation with the roots of 5 plus or minus the square root of 6. So when you are actually told to write the quadratic equation, you are going to follow this formula. So it's going to start with x squared, because it always starts with x squared. And then it's going to be minus the sum of your roots times x. So whatever you get when you add your two roots together, plus the product. And it's going to equal 0 or y. It really doesn't matter what you set it equal to, as long as it's equal to something. And then that's the formula we follow when we're trying to write the quadratic equation. So for our example here, we are told to write the equation. So we first got to figure out the sum of our two roots. So 5 plus the square root of 6 is one of our roots. 5 minus the square root of 6 is our other root. So I'm going to add those two together. 5 plus 5 gives us 10. And then what happens with our radical 6's? They cancel, so our sum is just 10. So then we'll figure out our product. So that means we have to multiply our two roots together. So 5 plus the square root of 6 times 5 minus the square root of 6. Do you remember what we call these two roots? It's the same thing, but the signs in the middle are changed. Conjugates. Do you remember how we multiply our conjugates? Conjugates. All you have to do is multiply the first two. So that gives me a 25. Multiply the last two. So that gives me minus the square root of 36. But what's the square root of 36? So what's 25 minus 6? 19. So our product is 19. So now to do our last part, what they actually wanted us to do in the problem was write the quadratic equation. So it would be x squared minus the sum, which was 10, times x, so minus 10x. And then plus your product, which was 19. And then equals 0. So x squared minus 10x plus 19 equals 0. Now again, if you were told to write the quadratic equation, the alternative way to do it, and the way we did it back in 9th grade, is you would set it up, put your two roots in there, but then change the signs of them, and then multiply everything out. So it's a much longer process than this. This is going to be a little bit faster as you get used to it. Add your roots, multiply your roots, and then just plug it into your little formula there. So for number 3, we're going to verify that 1 plus or minus 2i are the roots of the equation x squared minus 2x plus 5. Fastest way of doing this, instead of solving it out like we were doing before, like we did on our warm-up today, find the sum, find the product, see if it matches the sum and the product from the equation. So let's figure out the sum first. Let's add the two roots together. So 1 plus 2i plus 1 minus 2i. 1 plus 1 gives us 2. And then your i's cancel because 2i minus 2i would just be 0. So our sum is a 2. Product, we're going to multiply the two of them. So 1 plus 2i times 1 minus 2i. One times 1 gives us 1. 2i times negative 2i gives me a negative 4i squared. Remember, i's follow the same rules as your variables, so that becomes I squared. Who remembers, what does I squared equal? Negative 1. So really, this is negative 4 times negative 1, which is a what? Positive 4. So 1 plus 4 gives us 5. So our product ends up being 5. So again, following along with our little formula up there, if I were to write my equation based on my sum and my product that I just found, it would be x squared minus the sum times x, my sum being 2, plus my product of 5 equals 0. Is that the same equation they have here? It sure is. So those are going to be the roots. And we just verified it. That's showing our work. That's us verifying that those are the roots. Go to the back. So we have, if one root of x squared minus 4x plus question mark equals 0 is 1, find the other root and c. Remember right here, That is our C. That's what we're looking for. We're trying to figure out what that last number is going to be as part of our trinomial up there. So far what we do know is we know our A value is a 1. B is a -4. C is our question mark. We're trying to figure that out. So based on what I know, I can work with the sum of my roots. I got my B value, I got my A value. Sum is -b over A. So that's why I know I can work with my sum. So if I plug in what I know, -4 over 1, which what happens when you do -4? Becomes positive, and then over 1 just means it's 4. So we know the sum of our two roots has to be 4. We know one of our roots is a 1. We don't know root 2, but I know if I add those two things together, it's got to equal a 4, because based on my equation, my sum of my two roots has to be 4. So what's our second root going to be? 3. Just subtract your 1. Your root number 2 is 3. So we've done our first part. They told us to find the other root. We found it. The other root is 3. So to get our C value, we should find our product of our two roots. So our first root was 1. Our second root was 3. So if I multiply those two together, my product is 3. 1 times 3 is 3. So in our equation, when we're trying to plug it in, remember this is x squared minus the sum times x plus the product. Our product was 3, therefore that's what your C value is going to be. That is your product. It's all about manipulating those two things. All right, then this one, last one, number 5. If one root is 3x squared plus question mark x minus 4 equals 0 is 1, find the other root and our B value. So again, I know A is 3. B is question mark. I know C is -4. I know that root 1 is a 1. Root 2 is also a question mark because that's what we're trying to find. We're trying to find our B value and our other root. So let's see here. We know C and A from our formula, so that's going to be product. So the product of our two roots is going to be C over A, which would make it -4/3. So when I multiply my two roots together, it has to equal a -4/3. So to figure out root number 2, I would do root 1 times root 2 has to equal -4/3 based on my equation. Well, anything times 1 is what? Itself. So 1 times root 2 is really still just root 2. So root 2 has to be -4/3. So we got first part. So now to figure out B is part of the sum, so I need to find the sum of my two roots. So 1 plus a -4/3. What is that going to give us? 1 plus a -4/3. Use that calculator if you need to help you add those together. 1 plus a -4/3. -1/3. So again, if we're using our equation, our sum formula is negative b over a. So I now know that needs to equal negative 1/3. Isn't a from our equation already 3? Right? A is a 3. So I can replace that with a 3, right? So what is b going to equal? A couple people already said it. Negative b would equal negative 1, because your numerators would have to be the same since your denominators are the same. So divide by negative, and b is going to be a 1. So root 2 was negative 4/3, b is a positive 1.